Dividing polynomials using the long division algorithm. First, a quick little recap on how to do long division with numbers that you learned a long time ago. Say we had like 180 divided by 12. How does that work? Well, I don't think about 12, how many times does 12 go into 1, because this is a, a two-digit number, and this is a one-digit number. So I think of it first as, how many times does 12 go into 18? 2 by 2 kind of deal. And the answer is once. All right, so let me get rid of those underlines. So 12 goes into 18 once, and for a total of 12 times, and then I subtract these and get 6, and I bring down the 0. And then I think, all right, how many times does 12 go into? So now I'm no longer thinking about 180. I basically, how many times go into 18? Get the number right here, subtract. Now I'm down here dividing. How many times does 12 go into 60? And the answer is 5. 5 times 12, 5 times 12, if I multiply these together, I get 60. And then I subtract, and because it is a factor, 12 is a factor of 180, then I get a remainder of 0. All right, so that's a little quick little recap. Let's keep that there, though. All right, so how do we do this? First of all, just like with the reverse tabular, you got to make sure it's in standard form. The exponents are in order. You're not missing any terms. 3, 2, 1, none. 1, none. Good to go. Okay, so x minus 4 is our divisor. That goes on the outside. 3x cubed minus 13x squared plus 6x minus 8, the dividend in the middle. Okay. Now, this is a binomial. It's two terms, so I am going to kind of be working just like I did over here. Like first I did 12 and 18. Well, that's going to be the same thing, but I am going to start off by thinking about it as front by front. So first thing I do is divide. Front by front is how I always say it in class. Front by front. That's very sloppy. But what I mean is I'm looking at the front term of the divisor and the front term of the dividend. What is 3x to the third divided by x? And the answer is 3x squared. Now the 3x squared gets put on top of the x squared here. See, this has a lot of structure to it, just like the tabular did, that things have to be in order. Like, I'm not going to put 3x squared here because then it's on top of an x cubed. All my x squared terms will end up in here. And all my x to the first terms here, and all my constants in a column here. We start off with simply divide. The front by the front. 3x cubed divided by x is 3x squared. Then, after you divide, you distribute. You multiply this by this to get something that goes here. So 3x squared times x is 3x cubed, and 3x squared times negative 4 is negative 12x squared. So it's just like we did here. Like when I put this 5 here, I multiplied it by 12 to put a 60 here. Then what did we do? We subtract. I subtracted the 12. I subtracted the 60. Now, subtracting polynomials, you have to subtract every term. So I have to minus 3x squared. And I have to minus negative 12. And subtracting a negative turns it into a positive. Keep change, or minus, minus. Minusing a negative becomes a plus. So you basically, the way I always think about subtracting polynomials is simply negating that polynomial. So I change all the signs down here and go from there. These will cancel out. The front pieces will also cancel out, much like this does. 18 minus 12 is 6. There's not a number here because these ones subtract out. The same thing's going to happen here. These will always cancel out. These might, or they might not. In this case, they don't. Negative 13x squared, positive 12x squared is negative 1x squared. And then just like I brought down the 0, I'm going to bring down my next piece, 6x. And then you were down here dividing 60 divided by 2. Well, now I'm down here dividing. So it really is the same structure. So you divide, you distribute, and then you subtract. Right, we divided to get this, we distributed to get this, and then we subtract these from the terms above them. Then I simply go back to the beginning and repeat the process. Maybe I bring down a term, but divide, distribute, subtract, repeat. So front by front, negative x squared divided by x. is negative x. Distribute it to both of the terms in the divisor. Negative x squared plus 4x. Negative x times negative 4 is positive 4x. But I'm subtracting these terms. So I'm changing their signs. These cancel. These don't. I get 2x. Bring down minus 8. Repeat. Front by front. 2x divided by x is 2. Distribute that 2 to xn minus 4. 2x minus 8. Subtract. Remainder of 0 is good. That means that x minus 4 is a factor of this polynomial 3x cubed minus 13x squared plus 6x minus 8. And the other factor is our answer up here, 3x squared minus x plus 2. Now, will there always be a remainder of 0? For now, but we will get to problems where we have remainders later. Do one more for you quickly, maybe a challenge one. It's not in order. There are holes. So first up top, what's my highest exponent? 4. So it's x to the 4th. Then I do have an x to the 3rd term, right? 5x to the 3rd. I do have an x squared term, minus 2x squared. Here's my 10x. Make that plus sign a little bit better, and here's my minus 8. So that has everything. There's no gaps in exponents there, but the denominator, the divisor, that does have a missing term. That's a 0x. So x squared plus 0x plus 2. All right, front by front, x to the 4th divided by x squared is x squared, and that goes in the x squared column. I distribute x squared to all of these things. I get x to the 4th. I'm going to write a 0x squared, even though it's not going to do anything, 0x cubed, sorry. But I do like to write it there just to keep my pattern. So x squared times 0x is 0x cubed. And x squared times 2 is 2x squared. Subtracting these, subtracting 0 doesn't do anything. Front piece cancels out. Second piece in this case does not. 5 minus 0 is nothing, so I get 5x cubed. Negative 2x squared and negative 2x squared, that's not 0. One of them would have to be positive. That's negative 4x squared. And I bring down my next piece. See, I'm kind of working as trinomials here because this is a trinomial. In the previous one, I kind of did binomials because this was a binomial, 2 terms. Because this has 3 with our gap there, I'm going to kind of work in pairs of 3 at a time. Front by front, 5x cubed divided by x squared is 5x. Distribute that out, I get 5x cubed, 0x squared, right? 5 times 0 is 0. But I'm going to write it as 0x squared because I want to keep the structure. You don't have to do that. But if I didn't do that, see, my next piece is 10x. If I didn't write that 0x, I might think the 10x goes here. And that would be a problem because these are not like terms. That'll make the subtraction more difficult. So I like to keep the zeros in there, even though they don't really do much other than keep my structure together. Subtract all this stuff. These cancel out. I end up with negative 4x squared. These actually do cancel out to 0x. Again, I'm writing it as a 0 to keep my structure. And I'll bring down my negative 8. Last one, front by front, negative 4x squared divided by x squared is negative 4. Sorry if you hear the announcements behind me. Bell just rang. Minus 4x squared, 0x, negative 8 when you distribute. Change their signs. Remainder, 0. Answer, up top. See you later.